Hello students, we are studying module 3. In this video, we'll be studying about message digest and one of the algorithm which is MD5. So as we have studied in the previous module that there are three important goals of security which is confidentiality, integrity and availability. Okay, so as we have seen in module 2 that there are different cryptographic algorithms, symmetric key or asymmetric key, which are used to achieve the confidentiality of the messages. So basically your encryption algorithms are allowing you to achieve the confidentiality. So what we can do to achieve the integrity? So let us first revise what is integrity. So integrity is basically to prevent the data or at least detect that somebody has modified your data. So it is about preventing the unauthorized modification of the data. So as you know that encryption is only providing confidentiality and it does not provide you integrity. So to achieve integrity we should have something different. So message integrity is what? So in the cryptographic systems that we have studied so far, they only provide the secrecy or confidentiality, but they are not providing you integrity. But however, there are some occasions where we may not even need the confidentiality or secrecy, but instead we must have integrity. So for example, if Alice may write a will to distribute her property upon her death. So the will does not need to be encrypted. So after her death, anybody can examine the will. So integrity of the will, however, needs to be preserved. And Alice does not want the content of the will to be changed. So in this case, integrity of the content is more important than the confidentiality or secrecy of the content. So one way to preserve the integrity of the document is by using the fingerprint. So if Alice need to be sure that the content of her document will not be changed, she can put her fingerprint at the bottom of the document. So the eavesdropper cannot modify the content of this document, or they cannot create a false document, because then the eavesdropper cannot forge the fingerprint of Alice. So to ensure that the document has not been changed, Alice's fingerprint on the document can be compared to Alice's fingerprint on the file. So if they are not same, that means that it means that the document is not from the user Alice. So the electronic equivalent of the document and fingerprint pair is the message and message digest pair. So to preserve the integrity of the function, the message is passed through the algorithm, or we'll call it as a function, which is called a cryptographic hash function. And this function creates a compressed image of the message that can be used like a fingerprint. So the message is given as an input to the cryptographic hash function, and then it generates a message digest. So the two pair, that is document and fingerprint, or message and message digest, they are similar with some differences. The document and the fingerprint are physically linked together, whereas the message and the message digest can be unlinked, or they can be sent separately. As most importantly, the message digest need to be safe from change. No, this hash function which we are using here is a one-way function, that from this message we can generate a message digest, but we cannot regenerate a message if we have this message digest. So this is a one-way function. Taking the integrity of the message by using this concept of message digest. To check the integrity of a message or document, we have to run the cryptographic hash function again and compare the new digest with the previous one. So if both are same, then we are sure that the original message has not been changed. So while sending the message, the sender will use the cryptographic hash function. Sender will generate the message digest. Now after receiving that, the receiver will again apply the same hash function to the current message and then generate the current digest. So this current digest is the one which is generated by the receiver by applying the hash function again, same hash function. And this is the previous digest, that is the one which the receiver has received from the sender. So you will compare both the message digest. If both of them are same, it means that the integrity of the message is preserved and then message is accepted. If it is not changed, it means that the message is modified and the integrity of the message is compromised. So in that case, the message would be rejected. Now let us understand the criteria for cryptographic hash function. So just like the one which we have seen in the block ciphers also, here whenever you want to generate a cryptographic write your own cryptographic hash function, it should satisfy these three important criteria. The cryptographic hash function must be pre-image resistance, it must be second pre-image resistance, and the collision resistance. So what is pre-image resistance? A cryptographic hash function must be pre-image resistance. It means that if a hash function is given to us, so if this h is a hash function and y is equal to h of m indicates that m is the message which is given as input to the hash function, and then it is generating h of m means hash of m. So it must be extremely difficult for the eavesdropper to find any message m dash such that y is equal to h of m dash. So whenever you are generating a writing your own cryptographic hash function, you must be sure that the eavesdropper, it should be very difficult for the eavesdropper to identify some different message m dash for that the same hash function hash or message digest is generated. So it means that for the different message the same hash should not be generated. So that is called as pre-image resistance. So if the hash function is not pre-image resistance, then eavesdropper can intercept the message digest, that is h of m, and then he or she can create a message m dash, and eavesdropper can then send m dash to the receiver, and he can then pretend that he is sending the original message m. Then the another criteria for the cryptographic hash function is a second pre-image resistance. So the second criteria is the second pre-image resistance. It ensures that the message cannot easily be forged. So if Alice creates a message and digest and sends both message and message digest to Bob, so this criteria ensures that Eve cannot easily create the another message that hashes to exactly the same digest. So here we can see that when we have given a specific message and its digest, it is impossible or it is very difficult to create the another message with the same digest. So Eve when intercept or has access to message m and its digest h of m, then she can create the another message m dash which should not be equal to m, but hash of m is equal to hash of m dash. So Eve sent m dash and hash of m dash to Bob. So Eve has then forged a message. Then the other criteria is a collision resistance. Collision resistance says that it ensures that the eavesdropper cannot find two messages that hash to same digest. So here the adversary can create two messages and hash to same digest. So suppose the two different wills can be created that hash to same digest. So when the time comes for the execution of the will, the second, that is the forged will, will be presented to the hearers. So because then the digest matches both the wills, the submission is undetected. That it is replaced or substituted. It is not detected. So that is called as collision resistance attack. So this message digest guarantees the integrity of a message. It guarantees that the message has not been changed. A message digest, however, does not authenticate the sender of the message. So when Alice sends a message to Bob, Bob needs to know if the message is coming from Alice. To provide message authentication, Alice needs to prove that he is Alice, or Alice needs to provide the proof that is Alice who is sending the message and not an imposter. So a message digest cannot provide such kind of proof. The digest which is created by the cryptographic hash function is normally called as MDC, that is modification detection code. It is only checking whether the particular message is modified or not. And the code can detect any modification in the message. So what we need for message authentication is a MAC, that is message authentication code. This modification detection code is a message digest that can prove the integrity of the message, that the message has not been changed. So if Alice needs to send a message to Bob and be sure that the message will not change during the transmission, Alice can create message digest or MDC and send both the message and MDC to Bob. Then Bob can create a new MDC from the message and compare the received MDC and the new MDC. If they are same, then the message has not been changed. So message can be transferred through an insecure channel, and eavesdropper can read or can even modify the message. But MDC, however, needs to be transferred through a safe channel. And the term safe here means that the channel which is immune to change, where nobody would be able to change the message. So if the message and MDC are sent through an insecure channel, the eavesdropper can intercept the message, change it, create new MDC from the message and send both to Bob. And Bob never knows that the message has come from eavesdropper. Now here we have to remember that the channel is safe. It means that there is a trusted party, and the term channel means that it is a passage of time through which we are sending the messages. So this is the concept of MDC. Then we have a message authentication code. So here to ensure that the integrity of the message and data origin authentication, that Alice, that is the originator of the message, is not somebody else. So we need to change a modification detection code to a message authentication code, which is called as MAC. So here the difference between MDC and MAC is that the second one includes a secret between Alice and Bob. So for example, the secret key that eavesdropper does not possess, so that can be used. So Alice uses the hash function to create a message authentication code from the concatenation of key and the message. So she then sent a message and the MAC to Bob over the insecure channel. Then Bob, after receiving it, will separate the message from message authentication code and then makes a new message authentication code from the concatenation of message and a secret key. And Bob can compare the newly created MAC with the one which he has received. So if the two MAC matches, then the message is authentic and it has not been modified by the adversary or eavesdropper.